Hello. Hello and welcome to this video. In this video, we will start learning about templates. Templates are quite complicated and big topic. Okay. Why complicated is because the syntax itself is complicated. And the second thing is that the error messages which you will get from compilers are insanely complicated. Okay. It is serious stuff dealing with template error messages. Things are becoming better with time, but still not what is the ideal situation. So, what are templates? Templates are a mechanism to write generic code. For example, you look at this maximum function. Okay, so you can instantiate this function and get maximum out of two values. The only condition is whatever type you pass to it, whether it is a basic type like integer, float, character, or complicated types, for example, custom classes, the only requirement is that it should implement the greater than operator. Okay. If greater than operator is implemented for a type, then this function will work. So that is the beauty of generic programming. You write code for a generic type, which we normally call T, okay? And then all the types which implement this greater than operator will work, or rather can use this function to find out the maximum out of two objects. So we can pass strings, characters, integers, floats, and many other standard library classes. So as you can see, the syntax, we have template followed by type name T in the enter brackets. So the syntax is that it is a template function which accepts a type T and returns a type T. This is the name of the function, takes two arguments of the same type T. So it's not that you can pass one int, one float. If you are passing int, both should be int. If you're passing float, both should be float. That is two objects of the same type we are passing to this function. And it compares them and returns the maximum out of both. Now we have another templates which takes two different types. They can be same but can be different as well. So this time we have two different type names, T and U, and the return value is automatically determined because we don't know which will get promoted to what. For example, one could be int, one could be long, and int will get promoted to long. We don't know that. That is why auto is the return type here. Name of the function is add. We have one parameter out of type T and another of type U. Then we have non-type template parameter. So it takes two arguments. One is a generic type T, another is a size underscore T type N. And this class has a data member of type T of size N. So it's an array of size N. Okay. The name of the variable is data. Now the const xpr size returns N. And then we have operator brackets for getting the index element at index I. Okay, it returns reference to that. And then we have a const reference which returns a const value out of that. So you can either modify or you can get. Now we have a class template. Here type name is T, which is the generic parameter. A data member is there of the generic parameter type value. And then it takes a value in the constructor and initializes that. Then we have get returns of type T, a const type, so returns the value stored in that class. Then we have full specialization. Now there are two things. One is called specialization, that is partial specialization, and then we have full specialization. Okay. So for example, this template does not have a generic parameter. It takes a parameter of type string. Okay. So it is full specialization. That is, this class will work only on string type, no other type. That is why full specialization. Now, there are two things which you will observe here. One is called full specialization, one is called partial specialization. For example, this one we can call partial specialization, okay? Because one argument is generic, another is non-generic. Similarly, there is partial full and then fully generic. For example, these are fully generic functions. And then there is something called instantiation, which we will see. Okay, instantiation means with what type you are invoking the function. For example, you can invoke maximum with type t, or rather int. So that will be instantiation with type int. And what happens is when I'm going a bit towards the compiler. What compiler does is, if it sees that maximum has been invoked with integers, then it will generate the code for integers and test that during the compilation whether the code works or not. And if there is a compilation error, it will report you it back. For example, in this maximum function, what will happen is that suppose you are passing two objects of class, same class, because you are supposed to send off the same class, and it does not implement this greater than operator. It does not overload that operator, then it will be a compilation error. The second thing which can happen is that we are sending two different objects of two different types. That will be also a compilation error, because the requirement is that both should be of same type. So whenever you invoke a generic class or generic method, by invoking generic class, I mean you create objects and invoke methods. So whenever you do that, for that particular type, code is generated from the template class or template functions, and it is actually compiled, and then you get to run it. So during the compilation phase, when the code is generated for the particular type with which you have instantiated the function template or class template, then you have got the compilation error possible. Okay, otherwise it will just work and none. So this is what we have. So box here is box we are seeing string. So similar to previous box, it is now a full specialization. Now we have partial specialization. We have a type name t and we print it. And in the storage, we take a t pointer and print pointer storage. You'll see why it is called partial specialization. Then we have in C++ 14 variadic template. So it takes a type name t, and of that type variable pi is constructor of t with the value of pi. We have alias templates. So don't worry about this. Okay, we will discuss this later. First, I want you to focus on this much. All right, up to here. We will see these are advanced issues, and I don't want to get into these right now. Okay, so the focus of the program which you should have is the maximum function, the add function, the fixed array, and box classes. Okay, rest of it, and of course the storage. Okay, so see there are two storages here. One is plain storage class and another which takes a t pointer. So we will restrict ourselves to this discussion to only these many stuff. After that, there are more advanced uses of templates which we will not do. So for example, box fixed array storage. Okay. So we will not do this. Okay. Let me comment this out. And comment this out for now. Okay. So now we have that. Okay. So how the maximum is invoked? Maximum is invoked with same argument 5 and 8, and it will give us 8. Then 3.2 and 7.4, it will give us 7.4. Then we have add, we supply two different types. integer and double. These are doubles. By default, decimal value, fractional numbers are double. Okay. Then in class templates, we create, look at the syntax box, then you instantiate with int and call the constructor by giving the argument 50. Then you get this 50 by calling b1.get. Similarly, for string, you create another object b2 templates and you then get b2 get. Then in non-type template parameters, we invoke it with int and 5, which is the size underscore t. And for we iterate over the array, and we put integer values on each element of the array. Okay. So note that this array will be of type int. Okay. And then we print those values in the next line. Then we have partial specialization. We create storage S with integer and int pointer, and we print those. So let's see this in action. Let me invoke the shell, and we'll say g++ minus wall minus w errors minus std is equal to c++ 26 minus pedantic complex property, and we have a clean comparison, and we run this. So as you can see, whatever output we predicted has come here. Okay. So it is general storage, it is pointer storage. For partial specialization for the array, we have 0, 10, 20, 30, 40. For class templates, we have 50. For fully specialized templates, we have string templates. For multiple template parameters, sum is 7.5, and for maximum, we have 8 and 7.4. So I will end this video here. You have got quite a bit of thinking to do about understanding the syntax. Let me show you an error, okay, that I was talking about, that errors can be complicated. So what we are going to do is, we are going to make this a double. And immediately you see that LSP server gives a problem. Oops. And if you try to compile it, oops, it will give you big problem. So it says no matching function call for the call to maximum. This is color code int and double. So there is one candidate, that is maximum TT. Template argument reduction substitution failed. Reduced conflicting types for parameter. So these are conflicting types. So a simple thing, and you have got this much problem here. Now assume you have inherited classes, and then there are exceptions, and then there are composition or whatever the complex stuff you can imagine. And this error can simply fill probably 5 pages worth of text. Okay, so that is one big downside of templates. The error messages, you have to go through a lot of text and actually understand what is going on. So this is one big problem or downside of templates. So with this, I will end this video here. What I expect you to do is, you take the code. I will put it in a gist. Let me put it in a gist. Okay. Right. Gist. I'll put the link of the gists in the video description. So we call it complex.only, and we put it here. And put it. Oops. Okay, very good. So we make it public gist, and you can copy the code from here. Okay, and there is a lot I have not discussed, starting from variable templates. We will look at these a bit later. Okay, there are some certain advanced concepts like CRTP or SANIEF or something like that. Substitution failure is not an error. So we will see this. There are concepts involved. So concepts came in C++ 20. And then you have got forwarding, you have got compile time calculations, and the CRTP I was talking about. Then we have default parameters. So a lot of stuff is there. We will slowly go through these. And trust me, templates is one of the most important aspects. I do not think any language has got the kind of generic programming facility like C++. And you can do a lot of magic with templates. You can write a lot of clever code with templates. You can implement a domain specific language kind of thing with templates. So a lot of things can be done with templates. Entire standard template library, as the name index, is written using templates. So make sure that you pay attention to this, and we will go through this slowly. And I'll end this video here. I'll take my leave, and we'll meet again after 4 days in another video of C++. Till then, I'll take my leave, and you have a great day and enjoy.